Hello, Mr. Clacton's digital electronics students. Um, so why are we going to study binary numbers? This is for Unit 1, 1.2.3. So 1.2.3, binary number system and conversions. And why do we need binary numbers? Well, binary numbers make it possible for us to have these items right here. Any electronic item you can think of benefits because of advancements um, in technology, and those advancements happen in large part because we were able to come up with a binary system to represent on and off, and you can see the zeros and ones here. So we're going to talk about number systems today, and talking about number systems, I think it's very important that we recognize what number system humans use and why they use it. So maybe you could think about that. I know I've asked that question in class before. If you need a little hint, then open up both of your hands and look down. How many fingers do you see? That's right. So we use the base 10 number system. The base 10, that's what humans use. Now what that means is we have these decimal places we all know for the base 10. We do have actually a decimal place. We see 10 to the 0. We see 10 to the first. We see 10 squared. The next place would be the thousands, 10 to the third, 10,000, so on and so forth. So you see that all these are just expressed as a power of 10. Well, for the binary system, in the binary system, we have base 2. And I know I've shown this to you, a lot of you before. So we have base 2. So here we have 2 to the 0, 2 to the first, 2 cubed, oh, whoa, Mr. Claxon, 2 squared, and 2 cubed. I always like to write the value of those numbers too. 2 to the 0. Any number to the 0 power is 1, 2, and you see a pattern here. It just doubles every time. So if I wanted to make the number 9, I would need 1, 0, 0, 1 would equal 9 using the base 10 number system. So when you see that subscript there, that is base 10. The only digits we have to use in base 2 or the binary number system are 0 and 1. That's it. Just like we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 digits for the base 10 system. So decimal to binary conversion, there are two different ways to do this. The way that the curriculum shows you is different than the way that I use, but I will show you both. Some people like that process, and they may use their calculator. They may be really good at mental math. So what does the curriculum show you? Well, the curriculum shows you this. Use successive division. So let's say that you're trying to convert 6, that's in the base 10 system, into its binary equivalent. What you would do is you start out with 6, and you're going to divide it by 2 each time. So 6 divided by 2 is 3. My remainder there is 0. So what I have to do is, I have to just list out a bunch of blank places. I'm going to pretend like I don't know how many are going to be filled. I know that I'm not going to need that much. And so now my least significant bit here, LSB, a bit is one of these. A bit is just one of these places. That's all it is. 1 bit, 2 bit, 3 bit, 4 bit, 5 bit. I'm sure you can make a song out of it. So there is my LSB. LSB, least significant bit. And then I take the quotient, and that becomes my dividend. Okay, my dividend. My divisor is always going to be 2. So 3 divided by 2, well, 2 goes into 3 one time with remainder 1. So where does that remainder 1 go? It would go in the next bit. See how we're working right to left here? That's why I do not like this method. We take the quotient. That becomes our dividend. 1 divided by 2. 2 goes into 1 0 times with a remainder of 1. So they say that 6 base 10, those 3 dots there mean therefore, should have a comma there, 6 base 10 is equal to 110 base 2. Now, and then you would use these places, right? What I would do there, honestly, this is the method that I support. I just make my places, and it's almost kind of like a guess and check. And then I say, okay, I have 2 to the 0, 2 to the first, 2 squared. Once you do this so many times, you won't need to do it anymore. I know that the value of that place is 1, the value of the middle place is 2, the value of the most significant bit here is 4. If I wanted to, I mean, I may take it one more, but then I realize, wait a second, that's 8. I need to make 6, so I'm not going to need that. So you might even do this and you're like, oh, I don't need that. 2 to the third power is 8. Not going to use it. Now, how would I make a 6 here? How would I use 4, 2, and 1 to make a 6? Well, I would use the 4, and then I have 2 more, right? So I need 2 more. Oh, there it is. 1, 1, and then I wouldn't use that last digit. So 1, 1, 0, and that is the base 2 system. So that's what I would do, just to show you. And it does help with some of the longer numbers. It's tougher. Some of the larger numbers, I should say. So this example right here, you got 2 different methods you could use. You could use 26, and you're going to divide by 2 each time. 26 divided by 2 is 13. So we've got 13 here. And what is our remainder? Remainder 0. So I would have to list out my bits, least significant bit, all the way on the right there. And I would just list a bunch of them out. And then I would start filling that in. I just use my remainder, right? And then I take 13 and say 13 divided by 2. 13 divided by 2. I know that's 6, remainder 1. So I know 1 would go here. And I have a 6 divided by 2, 3, remainder 0. I'll put a 0. And then I have a 3 divided by 2. And that goes in 1 time. 2 goes into 3 1 time with a remainder of 1. So there would be the 1. And then I have a 1 divided by 2. Goes in 0 times with a remainder of 1. All right. So let's see if we did that correctly. I'm just not using that place. 1, 1, 0, 1, 0, base 2 should equal 26. Now, what I would have done, honestly, I just would have made some places here, take you through this process, and you actually get to pick which method works for you, right? I just list out a bunch of places. We have 2 to the 0, 2 to the first, 2 squared, 2 cubed. Now, as I'm listing these out, I know that we have 1, 2, 4, 8, 16, and I would not need to go to 32 because I'm just trying to make 26. So I really don't need that place. And I would just fill these in from left to right. I like this because it works left to right, just like we read books here in the United States. So looking at this, I know that I need a 16. And again, I'm trying to make 26. So it's almost like a little game. Well, maybe if you're a geek, it's a game. I like numbers, right? And you don't have to be a geek to like numbers. You just have to, appreciate. What else do we need? Well, if I had an 8, 16, 8, that would make 24. I'm almost there to 26, right? I almost got 26. Oh, that would leave me too much if I added 4. So I have 24 now. 16 plus 8 would give me 24. Oh, I just need the 2. and I fill the others in with 0, 1, 1, 0, 1, 0, base 2. So my answer there, if I want to be really fancy, therefore, we would say 26 base 10 is equal to 1, 1, 0, 1, 0, base 2. All right, so you get to choose which method that you like. This is the first video. I'm trying not to keep it, not to make it so long. Hopefully this was helpful to you. If so, just let me know. If these videos aren't helpful, then we do not need to continue doing this. I do not want to subject you to cruel and unusual punishment. All right, have a good class. I hope to see you all soon.